So we have convergent boundaries. We have several different convergent boundaries. This is where a lot of the really cool stuff that, as we're geologists, we really like. So we'll spend a little bit more time on this. First thing what you're going to have is convergent means they're coming together. So you have the two sides coming together. The most interesting for us is going to be the continental versus oceanic convergent boundary. So I'll draw that out. Okay, so on this we have two plates. We have continental. You can tell it's continental because it's big and fat. It's going to be felsic. You've got your oceanic. It is going to be newer, so it's thinner. It's going to be mafic. Why those two things are important is oceanic has got a density of, do you guys remember? 3.2. And then the continental will have a density of, do you remember? 2.8. I tend to test on that because it's fairly important. And then underneath we have the oceanosphere, and it has a density of 4.5. So because of this, everything's just basically floating along. The two come together. This is like a big old semi-truck. This is kind of like a, I don't know, small Volkswagen Bug or something like that. And so what ends up happening is these two collide, and one has to slide underneath the other. So you think, well, which one's going to slide underneath? Well, the one that is more dense. So the oceanic crust actually slides down and gets pulled down by these currents into the oceanosphere. As it gets pulled down, it physically will grab this crust, this continental plate, and it will drag it down with it. It will drag it down because there is friction. This way I'm right-handed. And so as it does this, it will literally crash, and then it will pull this down like this. And so the whole thing gets pulled down. And what you get then is a very deep area right here in the middle. So you have my continental coming, I've got my oceanic coming, they hit, and then the oceanic's going to go down, and as it does that, it's going to also drag the leading edge of the continental stuff down. Because it drags it down, this is going to be a deeper point. This is going to be called a deep sea trench. And of course, there is water because it is oceanic. So your shoreline's right here. Interesting then, the deepest part of the ocean is not the middle. Typically it's going to be 100 or 200 miles off the coast. So you have your boundary here, your coastal boundary, and then several hundred miles off the coast is going to be where the deepest point is. If you're in Oregon and you go out, 100 miles out into the ocean, it gets very, very, very deep because we're in a trench. Further on, if we look to see what then happens to this oceanic material as it goes down, it then starts to get hot, and so it melts. See, that was fun. I had a little visitor in the middle of my lecture, and he's like going, "What? What are you doing?" Anyways, so this stuff goes down and it melts. It doesn't want to go down because it's not dense enough, and so what happens is it starts to burn its way through because it is hot and it's lower density because of that. So this stuff will burn its way through. As it burns its way through, it will eventually come up onto the surface as a volcano. And so we get a whole line of volcanoes right along this plate boundary. This is going to be like Mount St. Helens or like Mount Shasta or Mount Lassen, as the stuff melts and then comes back up. When you look at the crust between what's happening off the coast of California and going up into Washington, the leading edge or the ending edge is right about where Lassen is. So Lassen is the first volcano, and then the rest of them are going to be active as you're going further, and it's being fed by this oceanic crust that is diving underneath North America. This also occurs in South America. The plate's going to be called the Nazca, and it's going over to South America, and the whole Andes Mountains right here is going to be formed. So the Andes Mountains being formed by this plate being pulled down. Okay, that is continental versus oceanic convergent boundaries.